We've given an introduction to the completable future completion stage methods, kind of motivated why we need them to avoid blocking, talked a little bit about how they help to address some of the challenges we had with the earlier, more basic features, mostly having to do with blocking. But there's a whole lot of completable future completion stage methods. So we're now going to talk about how to group them together to think about them in smaller chunks, which is very helpful because, as you can see, there's a bunch of them. So completion stage methods, of which there's some 30 or more, can be grouped together based on how a given stage is triggered by one or more previous stages. Remember, the whole concept of a completion stage method is to be able to have dependent actions that are triggered when certain things finish. So we can then break things up into smaller subcategories based on how they're triggered. And you'll see here, it's roughly about a third, a third, a third. Some of these things will complete when a single previous stage completes. I think sort of the bulk of them probably do that. That's the brown color here in this sub pie chart. Some will also complete when two previous stages complete. That's the blue part. And then yet other ones will complete when either of two previous stages complete. And that's kind of the red part there. So we've got three subcategories within this overall category. So let's first give an overview of some of the key methods, some of the key completion stage methods that complete when a single previous stage completes. And as you can see, we've got 4 of them listed here. We've got then apply, which takes a function, a Java functional interface function, returns a completable future with the result of that function being applied, and the behavior is to apply the function to the result of the previous stage. So whenever the previous stage completes, then apply will run and apply the function on that and return a completable future to that. Then there's also a method called then compose, which looks very similar to then apply, except it returns a completable future with the result of a function directly, not a nested completable future. And at this point, you're probably like, what the heck is the difference between those two things? I will show that with some cool examples when we get a little bit later on. Again, the result of this is applying the function to the result of the previous stage. There's a method called then except, which takes a consumer, not a function, and it's going to return a completable future to void, meaning that there's no return value. And its consumer will handle the results of a previous stage. So it accepts it, it consumes it, but it doesn't return a value per se, just the fact that it completed. And then the final method here is the then run method, which is very similar to then except it takes a runnable, not a consumer. So the runnable, as you know, doesn't take a parameter, doesn't take any parameters, and it also returns void. And so it runs the action without returning a value. There's also another set of methods that have the same prefix but have a different suffix, which is the async word. And these methods will arrange to run the parameter, either a function, a consumer, or runnable, either in the invoking thread, if that's appropriate, or more likely in a different thread. And so, sorry, I said that wrong. The methods here that are the non-async versions run in the invoking thread or the same thread as the previous stage, depending on different factors. And then there's async variants of these methods that will run in some thread pool. So these methods, the ones that are the non-async versions, will run typically in the same thread as the previous stage ran in, whatever that might have been. And the async variants will typically run in a different thread in the thread pool. And it's very tricky to figure out which to use, and this little article will explain to you some principles and characteristics and properties to make your decision, some criteria, but it's a subtle issue, and we'll talk about that when we look at the examples in more detail. There are then a bunch of other methods that will be triggered when both of two previous stages complete. So you can think of them as AND operations. So these are completion stage methods that are triggered when the first and second of the previous stages complete. And there are 3 of them. There's then combine, then except both, and run after both. Then combine takes a by function as the parameter, which has basically it expects to take 2 parameters, and it returns a completable future with the result of calling that by function. And it'll apply the by function to the results of both previous stages when they complete, when they trigger. Then except both takes a by consumer, so it's a bit like the method we saw over here. Then except it will be called when 2 things complete. So it takes a by consumer and it returns a completable future to void. And it handles the results of both previous stages but doesn't return a value. And then we have run after both, which is like then except both, except it takes a runnable, not a by consumer. So that's a bit like then run, except it only gets triggered when both of the previous stages complete. So these methods are typically used to join together 2 asynchronous forked computations and then do something else when they're done. You can see here that we have both the non-async versions and the async versions of these. And whether to choose one or the other depends on various factors, like how long do the parameters take to do their thing. And then the third and final type of completion stage method will be triggered when either of 2 previous stages complete. So you can think of these as effectively like or disjunctive mechanisms. And again, we have apply to either, which takes a function, and whichever of the 2 completable futures finishes first, that function is applied. You have except either, which is much like apply to either, except it takes a consumer, and the consumer will consume the results of either one, but not return a value per se. And then there's run after either, which takes a runnable, and it's very much like except either, and it'll run whichever one finishes first. Now, an interesting little side note, which we'll talk about more when we get to this a little bit later, is that these or disjunctive style of completion stage methods don't cancel the completable future that was not finished first. So that thing will continue to run until it's done, and there's various reasons for that. We'll talk about that when we get into the example in a bit more detail later. So those are the 3 categories of completion stage methods. There's a group of them that will be triggered, which will trigger their dependent action when a single previous stage completes. There's some that will trigger when both of the previous stages complete, and there's some that trigger when either of the previous stages complete. Now, there's also yet another category we'll talk about later called the arbitrary methods, which take the concept of this composition notion we just talked about and generalize it to n completable futures. So all of, which is an arbitrary method, will wait until all the completable futures are done before it triggers the completable future, and any of will trigger when any of those completable futures finish. So those are basically extensions of this, but I separate them into a different category because they're used in quite a different way, and we typically have to encapsulate them for reasons we'll talk about when we get to that part of the course.